The ISO standard also explained that usability depends on the users and on contexts. Indeed, regarding computer system design, we have to think of the target users and to develop the computer system according to them. It can include age-specific needs for older people, for example, people with disabilities, a prior technical knowledge, etc. If we design a computer system for someone like me, for example, we won't do it the same way as if we want to design a system for a professional or for an older person. Here are two concrete examples. An airplane pilot or an air traffic controller will need a computer system allowing him to make few mistakes. It has to be completely reliable. The effectiveness and efficiency criteria will be very important. However, satisfaction is less important. The pilot's pleasure when using the system is less important than his ability to pilot. It is then completely different to create an interactive system for a museum. For example, in a museum, we will want the user to stay in the exhibition and to take some time to play with it to experiment. In this case, satisfaction is very important. To create a usable systems, there are 3 design processes possible: user-centered design, participatory design, and co-design. The user-centered design will take into account the needs of people, but without directly involving them in the design process. How can we do that? Some recommendations exist, such as ergonomic criteria that we can use to design systems, but also to assess the system after designing it, so we can make sure that this system meets those ergonomic criteria. Then, there is the participatory design that goes further because it involves the users during the design process. We will generally identify 4 steps. The first one is an analysis phase. We will watch the users while they carry out tasks. We will also create questionnaires or interview people. The second phase is about the creation of ideas, in which the users will be involved too. For example, during brainstorming, we will ask them to participate in the creation of ideas, to find solutions to their needs. There is then a prototyping phase in which we will design different prototypes. They can be high-fidelity prototypes that are really encoded. They can also be low-fidelity prototypes, such as sketches on paper which enable to draw the interaction with the system. And there is the last assessment phase, during which we will do users' tests that enable us to put the real users in front of the system they have designed. This process is iterative. After an assessment phase, we can start a new process, a new cycle, and start an analysis phase again to find out if the prototype designed really meets the user's needs. There is also a multidisciplinary process. We shouldn't only have software developers, the teams should be mixed, with ergonomists, for example, or human factors specialists. Ultimately, there is the co-design process in which we go even further, in which users become system designers. We will ask them to design their own system. Today, this is possible thanks to the Fab Labs movement, for example, which enables any user to have access to 3D printers, laser cutting machines, or electronics such as the Arduino or the Raspberry Pi so they can design their own computer system. The computing devices that we currently use every day come from computer labs. For example, the computer mouse was brought to the United States by Douglas Engelbart in the 1960s, but was tested beforehand in research laboratories. The touch screens that we find in smartphones today have also been undergoing tests in research laboratories since the 1960s, whereas the first commercial prototype was marketed in 2007. Nowadays, there are also computer systems that go beyond computers. For example, ubiquitous systems that we find in our homes, our cars, phones that are constantly with us, and that we might even have one day in our clothes. We can also see the commercialization of virtual reality and augmented reality systems. What is augmented reality? It aims to overlay virtual information on real information that we perceive. For example, glasses enable us to perceive reality, but we can overlay virtual information. What can we expect in the future for human-computer interfaces? For example, HCI has the possibility to give access to information to a maximum of people. I am referring to the aging society, for example. Our mission is to design systems that older people can use as their eyesight is poorer, or as they may have cognitive problems. And it will be even better if we design systems that can support them in their daily life. For example, to remind them to take their medicines or to detect falls. I am also referring to people in developing countries or disconnected from everyday life, from society, who could access information via computer science. These interfaces enable the user to interact with a computer only by measuring brain activity. And one of the HCI tasks is also to link different computer fields such as big data, artificial intelligence, or robotics.